Just over 4 light-years from Earth, around a small red star, lies a world that has fascinated astronomers for years. Its name is Proxima b. It is one of the closest known exoplanets to our solar system, making it an obvious target for scientists searching for clues about planets beyond Earth. But Proxima b is also an extremely challenging world to study. Its host star, Proxima Centauri, is a red dwarf. Although smaller and cooler than our Sun, it is capable of powerful stellar eruptions that could bombard nearby planets with radiation. And yet, Proxima b remains fascinating because it orbits within the region where temperatures might, under certain atmospheric conditions, allow liquid water to exist. That does not mean the planet is habitable. It does not even prove that Proxima b has an atmosphere. But it makes the world worth investigating. Now imagine that future observations revealed an unusual glow coming from the planet. Not a bright signal. Not something visible from Earth with the naked eye. Instead, imagine an extremely faint infrared emission that appeared to change in a repeating pattern. At first, scientists would probably assume the explanation was natural. Perhaps the signal came from the planet's atmosphere. Maybe charged particles were interacting with its star. It could even be caused by thermal radiation from the surface. Every possibility would have to be tested. That is what makes the hypothetical discovery so interesting. If a repeating pattern survived multiple observations and could not be explained by known planetary processes, researchers would have to consider more unusual possibilities. One of them would be artificial illumination. On Earth, artificial lights have become a recognizable signature of technological civilization. From orbit, enormous cities can produce a faint glow across the night side of our planet. Could something similar ever be visible on another world? In principle, an advanced civilization could produce artificial light for many reasons. Cities might require illumination. Underground settlements could use enormous energy systems. Orbital infrastructure could reflect or generate light. But detecting such activity on an exoplanet would be incredibly difficult. The planet is extremely far away, and its star is vastly brighter than the world surrounding it. Separating the tiny signal of a planet from the overwhelming light of its star is one of the greatest challenges in exoplanet astronomy. This is why scientists rely on sophisticated instruments and indirect techniques. Infrared observations are particularly valuable because they can reveal information about a planet's temperature and atmospheric composition. Researchers can examine the wavelengths of light associated with molecules such as water vapor, carbon dioxide, methane, and other compounds. But even detecting one of these molecules would not automatically prove life. Natural chemistry can create many of the same substances. That distinction is crucial. A genuine discovery would require multiple independent pieces of evidence. If an unusual infrared pattern were ever detected around Proxima b, astronomers would likely observe it again using different instruments and at different times. They would compare the signal with stellar activity. They would check whether the pattern changed when Proxima Centauri produced a flare. They would examine whether the signal matched the planet's expected rotation or orbital behavior. Only after eliminating natural explanations would the possibility of technology become scientifically interesting. And there is another fascinating question. If Proxima b is tidally locked, one hemisphere could potentially remain facing its star while the opposite hemisphere experiences prolonged darkness. Under the right atmospheric conditions, heat could be transported between these regions. A hypothetical technological civilization might also adapt to such an environment in ways completely different from life on Earth. Perhaps it would build beneath the surface. Perhaps it would use artificial illumination. Or perhaps its technology would leave no visible signature at all. For now, these ideas belong to the realm of possibility rather than established discovery. But the search continues. Because the closer astronomers look at neighboring worlds, the more complicated the universe becomes. And Proxima b may still have a surprise waiting for us. The biggest question surrounding a hypothetical glow from Proxima b would not be whether it looks strange. The real question would be whether nature can explain it. Astronomers know that planets can produce unexpected signals. Auroras can create light. Volcanic activity can release enormous amounts of energy. Atmospheric chemistry can generate unusual infrared signatures. Stellar radiation can interact with charged particles and produce emissions that appear periodic. So if a faint signal were detected from Proxima b, scientists would have a long list of natural explanations to investigate before considering technology. This process would be slow and extremely demanding. Researchers could compare observations from space telescopes with measurements from powerful ground-based observatories. They could examine the planet at different wavelengths. They could monitor Proxima Centauri itself to determine whether stellar activity was responsible. And they could search for repeating patterns that remained synchronized with the planet rather than its star. That last possibility would be particularly intriguing. Imagine that an infrared emission repeatedly appeared during the planet's night side and disappeared during its daylight period. Even then, it would not automatically prove the existence of cities. But it could provide an important clue. A civilization does not necessarily need to produce visible city lights. Advanced technology could generate waste heat, radio emissions, laser pulses, atmospheric pollutants, or enormous energy structures. These are known as technosignatures, observable effects that could potentially indicate technological activity. The search for technosignatures is already part of modern astronomy. Organizations studying extraterrestrial intelligence have traditionally focused heavily on radio signals, but technology could theoretically reveal itself through many other forms of radiation. Infrared observations are especially interesting because every technological system produces heat. A civilization using enormous amounts of energy would have to dispose of that energy somehow. That waste heat could potentially leave a detectable signature. But detecting it from more than 4 light-years away would be incredibly challenging. The planet's signal would be incredibly faint, while Proxima Centauri would remain overwhelmingly bright. Future observatories may improve this situation. Next-generation telescopes could offer better instruments for separating planetary light from stellar glare. Advanced coronagraphs could suppress the star's brightness, while other proposed technologies could potentially block starlight before it reaches a telescope. The goal is simple: see the planet itself. Measure its atmosphere. Study its surface conditions. And determine whether anything unusual is happening there. If scientists eventually discovered a persistent signal that could not be explained by geology, atmospheric chemistry, stellar activity, or instrumental effects, the implications would be enormous. It would not immediately mean aliens had contacted Earth. Instead, it would mean astronomers had found something genuinely unexplained. The next step would be confirmation. Independent observatories would attempt to reproduce the observation. Different instruments would search for the same signal. Researchers would publish their methods and data so that other scientists could test the result. Only after repeated confirmation could the scientific community begin discussing technology as a serious explanation. And if that happened? Humanity would face one of the greatest questions in its history. Are we alone? Proxima b is close enough to make the question feel almost tangible. At roughly 4.24 light-years away, it is practically next door on the cosmic scale. Yet even a message traveling at the speed of light would take more than 4 years to cross the distance between our worlds. Any conversation would therefore unfold across enormous stretches of time. Perhaps the most important discovery would not be an alien city. It might simply be evidence that another world possesses chemistry, energy, or environmental conditions unlike anything we have seen before. And that alone could transform our understanding of planetary science. For now, no confirmed evidence shows that Proxima b has artificial lights or an advanced civilization. The mystery remains open. But that is exactly why scientists continue looking. Every new telescope gives humanity a sharper view of worlds that were once nothing more than tiny points of light. And somewhere around a distant red star, Proxima b continues its silent journey through space. Maybe it is completely natural. Maybe it hides an atmosphere unlike anything in our solar system. Or perhaps, one day, astronomers will detect a signal that forces us to reconsider our place in the universe. Until that day arrives, the search continues, one photon at a time.